In this chapter we will discuss a few elementary functions which are important because even more complicated functions are often composed or built using these elementary functions. So, first, a constant function has a graph which is a horizontal line. A linear function has a graph which is a straight line. So a constant function like we say just y is b. Then the quadratic function, the first or simplest quadratic function is y is x squared. The graph is parabola. Parabola is something that you know that you can see in your life. If you consider motion of a point like that in the homogeneous gravitational field, then the trajectory of such a point is again such graph, such parabola, this time upside down. If you take a parabola and you rotate the curve, a surface is generated that you can see in the cities, on windows and on houses, when people want to receive satellite television. The antenna, the aerial, the metal plate is in the form of a rotational paraboloid, and the reason is that the rays that come from a large distance are reflected into a single point called focus, and then the signal is very strong, so it looks like a noiseless amplifier. Related to this function is the square root. The relation between these two functions is an important relation which we will discuss in more detail when we will be talking about inverse functions. If we change the exponent from 2 to 3, we get a cubic function which is for positive x roughly similar to x squared, but the great difference is that for negative x squared gives positive results, while x cubed for negative x gives negative results. And we can consider the cube root of x with a graph like that. Then the important function is 1 over x, reciprocal value. It is not defined as 0. For positive x, the result is positive but decreasing. And for negative x, the result is negative and decreasing in this interval. If we change the exponent from -1 to -2, then for positive x, it is similar, not identical, just similar. But there is again a big difference for negative arguments, because x squared gives positive results as opposed to negative results of 1 over x. Then an important function is exponential function. If we call a function, say 2 to x, then for 0, the result is 1. For positive x, it increases very quickly. And for negative x, it goes to 0 very quickly. It never touches the x-line, it only approaches or converges or goes closer and closer to the x-line. If we change the base from 2 to any number greater than 1, we have a qualitatively similar picture. While if the base is between 0 and 1, then the function is decreasing. Especially when we change the base to e, magical number, we will be discussing in much more detail very soon. Then we have the function e to x, and the inverse is logarithm, which has the graph like that. Once again, we will be discussing the logarithm and inverse functions in much more detail very soon. Then we have the goniometric functions, sine, cosine, and tangent. And corresponding inverse functions, which we will discuss later. It's good to know the graph of the function y is absolute value of x. For 0, the result is 0. For positive x, we can remove the absolute value, it's just x. But for negative x, we have again positive result, which gives a function like that. Then we have an important function called signum or sine, which denotes whether there is plus or minus at the beginning of writing the value of x. If x is positive, the sign of a positive number is plus 1. If the argument is 0, the result is 0. And if the argument is negative, the result is minus 1. So this is called sine or signum as a function. These stepwise functions are often used in control theory to describe devices like switch. Switch may be turned on or turned off. So these values, which have finite number of values, these functions which have finite number of values, are used as a good description of these devices. And the last function in this table corresponds to square, to circle. Yeah, let's do it here. Consider the unit circle. Center at the origin, radius 1. This can be described as x squared plus y squared is 1. This curve as a whole is not a graph of a function, because for a function we want for each x to have one result, for each x in the domain of definition. In general, for each real x to have at most one result. 0 results when we are out of the domain, and 1 result when we are in the domain. But here we have one result for x is 1 and one result for x is minus 1, but we have two different results for arguments between minus 1 and 1. So this curve as a whole is not a graph of a function. But what we can do is to consider only the upper half of the circle, and if we solve this for y, and we take non-negative y, we have y is square root of 1 minus x squared. So this upper part of the unit circle is the graph of this function. As an alternative, we can consider the lower part of the circle, and that would correspond to the other root of this equation. Y is minus square root of 1 minus x squared. So this is the graph of this function, and this is the graph of this function. Two halves of a unit circle. And the circle as a whole is not a graph of just one function. So to conclude this observation, for a function, we want just one result, no more. To be honest, in some parts of mathematics, some authors use objects like multi-valued functions. Yes, objects like that exist, but we will not consider multi-valued functions. So that was the collection of a few elementary functions, and in the next chapter we will consider composition of functions.